Our next question is the heat required to raise the temperature of a metal by 30 Kelvin is 36,000 joules. Calculate the heat capacity of the metal. The heat required to raise the temperature of a metal by 30 degrees Celsius is 36,000 joules. Calculate the heat capacity of the metal. So they have already given us the heat. So we shall use Q to represent heat. The amount of heat is already given here in joules, 36,000. Then there is 30 Kelvin, that is the temperature, that is the theta. Representing temperature is 30 Kelvin. And the question is calculate the heat capacity. Heat capacity we use capital C. So it's under question mark. So we shall use this formula. Q is equal to C theta. That formula connects quantity of heat, temperature change, and heat capacity. Q, which is the amount of heat, equals to the heat capacity, that is capital C, times theta, which is a change in temperature. Now we are going to substitute. Where there is 36,000 joules, we shall now take that one where there is a Q, that is a quantity of heat. Capital C, we leave it the way it is because it's the one we are looking for, times 30, that is the temperature, 30 Kelvin. And after substituting this, you multiply C times 30 is 30C, giving us being equal to 36,000. So because we are interested in C, we are going to divide it by 30. So 30 divided by 30, you get 1. 1 times C is the same as C. Then we shall also have 36,000, this one, divided by 30. That one we are going to get 1,200 as the answer. Now remember we are calculating the heat capacity. And we said the SI unit of heat capacity is either joules per Kelvin or joules per degree Celsius, depending on the temperature. Now when you look at the temperature, it was 30 Kelvin. So our answer should be joules per Kelvin. There are 3 marks. How do we get all? The formula takes 1, substitution takes another 1. The answer and the unit will share the remaining 1 mark. At the end of the day, you get all the 3 marks. That is very good. Now let's look at the second question. 100 grams of water at 70 degrees Celsius is added to 200 grams of water at 10 degrees Celsius, and the mixture well stirred. See? Neglecting heat absorbed by the container. Find the final or the maximum temperature. Now this question reminds me of some people when you are going to bathe, you mix hot water and cold water. And when you mix the two, you end up with warm water. So we have hot water. You see? 100 grams of water at 70. That is the highest temperature. Then we have another water at 10. So this one at 70, because it's the highest, we shall call it what? Hot water. So the hot water, there are 3 temperatures. Theta 1, that is for the cold one. Then theta 3 for the hot one. Then after mixing, you end up with what? Warm water. The temperature of warm water is always greater than cold water, but less than hot water. So it is in the middle between the hot water and cold water. So we shall have this one as the lowest for cold water, followed by this one which is for warm water, and then the hottest is what? 70, which is theta 3. So we have 3 temperatures. The smallest is the cold water, followed by warm water, and finally the hot water. So what happens when you mix cold water and hot water? Cold water and hot water, you end up with what? Warm water. Not so. So what happens? The hot water loses heat. You see this arrow? Loses heat from theta 3, which is 70 degrees Celsius, up to the temperature of the warm water, which we want. Then the cold water gains heat from theta 1, which is 10 degrees, until it goes up to the temperature of the warm water. So this is the temperature which we are looking for, and is the final temperature. After mixing this and this, you get this. So when I say I want the final temperature, in this case I want the temperature of the warm water. So let's go to our calculation. We have realized that the hot water loses heat. So heat lost by hot water equals to heat gained by cold water. But in reality, this cold water is in a container. So when the water gains, the cold water gains heat, even the container gains heat. You see? But we have not talked about the container. Why? Because of this word. Neglecting heat absorbed by the container. So the heat which is absorbed by the container, we should neglect. Should be neglected. And because we are neglecting it, we shall not even talk about it. So we shall only remain with the heat lost by the hot water equals to heat gained by the cold water. The formula for calculating heat is mass times specific capacity times change in temperature. Now this small triangle means change. So if this is the temperature, change in temperature. So the hot water is changing temperature. How is it changing? From 70, which is theta 3, up to theta 2. Then the cold water is also changing the temperature from 10 degrees. That is from theta 1. It is increasing up to what? Theta 2. So there is change in temperature in both cold water and hot water. So as I said, the formula remains the same. MC, mass times specific capacity times change in temperature. Even the heat gain is also mass times specific capacity times change in what? Temperature. Now let us substitute. Where there is a mass for hot water, the mass was what? 100 grams. So the SI unit of mass is not grams, it is kilograms. So we have to change this mass to kilograms by dividing by 1000. You see? So our mass here is 100, but you divide by 1000 to change grams to kilograms. Time is the specific capacity of water. This is C. The specific capacity of water is known. It is a constant and it is 4200. Time is the change in temperature. For the hot water, we said it is from 70 to, so which one is bigger? Theta 3 is bigger than theta 2. So it will be theta 3, which is 70, minus theta 2. So that's what you write here. Then when you go to cold water, the mass was given us, you see, 200 what? Grams. So we also divide it by 1000 to change the grams into kilograms. Times the specific capacity of water. Whether the water is hot or cold, the specific capacity remains what? The same. So the specific capacity is 4200. Times the change in temperature. For cold water, how is the temperature changing? From 10, it is increasing to theta 2. So when you look at theta 1 and theta 2 is bigger. So when you are subtracting, you get the big one. You don't say theta 1 minus theta 2 because theta 1 is small. It is theta 2 minus theta 1. But theta 1 is already given as 10. So it is theta 2 minus 10. So you write here theta 2 minus 10. Now, you can now multiply these figures. You deal with these ones. You multiply this 100 times 4200 divided by 1000. You get 420 before you touch the bracket. So whatever you get outside here must be multiplied with what? The bracket. Then this side also you do the same. Equals to 200 divided by 1000. You get the answer times 4200. You get 800 and what? 40. Before you touch without touching the what? The bracket. So whatever you get out here, which is 840, multiply with the what is in the bracket. Then now you can open the brackets. 420 times 70, you get 29,400. Minus, you put the minus here. 420 times theta 2, you get 420 theta 2 equals to, we are now crossing over. 840 times theta 2 is 840 theta 2. Minus, you put the minus. 840 times 10, you get 8,400. Now, when you reach here, you collect the like terms. You can leave the theta 2's this way, then you leave the numbers this way. Now, 840 theta 2 is already here. So you bring the friend. The friend is here. Because here it was negative. When it crosses, it becomes what? Positive. You add. Then this side we have 29,400 already this side. So you leave it there. But you bring the friend. The friend is here. the number. So here it is a negative. When it crosses, it becomes what? Plus. When you add this, you get 37,800. When you add all these theta 2's, you get 1,260 theta 2. Now you divide both sides. You want to remain with the theta 2. So you divide both sides by 1,260, 1,260. Now 1,260 divided by 1,260, you get 1. 1 times theta 2, you get theta 2. Then when you divide these two with your good calculator, the answer will be 30. So therefore, theta 2, which is the temperature of the warm water, the final temperature after mixing the cold water and the hot water, is supposed to be 30 degrees Celsius. So how many marks were given? There were 3 marks. 1 is for the formula, 1 is for substitution, a half for the answer, correct answer, not just answer but the correct answer, which is 30, then a half for the unit. And you get all your 3 marks. Let's go to the next question, which says, describe, and question 2, describe an experiment to demonstrate convection in liquids. And I've given here 8 marks. You see, it is an experiment. It has very many marks, 8 marks. So we are supposed to get all these marks. So what do? We draw the diagram. But before we draw the diagram, I want to remind you that when you are boiling water at home, normally you get a saucepan, put water and a source of heat. You heat the water until it boils. Now in the laboratory, our saucepan is going to be the round-bottomed flask. This one is a round-bottomed flask. So it is going to be the round-bottomed flask. Now, look at that round-bottomed flask. So inside the round-bottomed flask, we are going to pour water. And after pouring water, we shall have a source of heat. Look at under the round-bottomed flask, there is a Bunsen burner. That is the source of heat in the laboratory. Now, there is also what we are calling there a crystal of potassium permanganate. So what do? When we have all this, we shall get water we pour inside a round-bottomed flask. Then we get a crystal of potassium permanganate. We drop it gently. If you drop it in a hard way, it is going to hit the bottom of the round-bottomed flask and it will break. Remember, the round-bottomed flask is made out of glass. So you pour water inside the round-bottomed flask. After that, you drop a crystal gently, a crystal of potassium permanganate, which is purple in color. Drop it at the center, in the middle, but at the bottom of the flask. Then you heat it using a Bunsen burner. Now, the source of heat must be directed where the crystal is. Look at the diagram. The Bunsen burner, the flame, very small flame, is directed where the crystal is. Now, when you heat this crystal, the first thing is the crystal will dissolve. And because it is purple in color, after dissolving, it will turn the whole water to become purple. So, this is what we call a workable diagram. Very nice looking diagram, and it is properly labeled. So you get your 1.5 mark there. Then you move and describe exactly what I've told you. First thing first. The first things first. So what do you do first? You get a crystal of potassium permanganate. You see, a crystal of potassium permanganate is gently dropped centrally at the bottom of the round-bottomed flask. So you drop the crystal gently, and you make sure you drop it at the center and at the bottom of a round-bottomed flask. Now the key word is here. You see where the marker is. Dropping it centrally, gently and centrally, then at the bottom of the round-bottomed flask. Then after that, the flask is what? Heated. You see? The flask is heated, and when you are heating it, you use a small flame. You see? Use a small flame. So you use a small flame. Use a small flame for heating. Now you go to observation. What happens? You are going to see. The water rising up and then falling outwards. So you see that diagram, how the convection current is set. So that diagram alone, and then you name it as convection current, and see what? The mark. Then you say the purple streaks of water rise upwards and spread outwards. You see, they rise upwards and they spread what? Outwards to form a convection current. So you get your marks for observation, the diagram, and then saying the water, the purple color, rising upwards, you earn, then spreading outwards, you earn, and forming a convection current, you earn. Then finally, you come and earn for the conclusion. You conclude after observing. And what is the conclusion here? The purple color, or the purple streaks of water, rise upwards and spread outwards due to convection current formed. In other words, you are giving a conclusion. The reason why the purple color spreads outwards and why it rises what? Upwards is because of the convection current which has been what? Formed. And you get all your marks. Thank you.